Hello dear students, today we are solving the Actuarial Science CS2 paper. This was a very interesting paper this year, so I will be solving in some videos the entire set with one by one and as much as explanation possible. Okay, so the classes you can join us for a specialized session at just text me at this number. So, without further ado, let's just jump into the first question. So, a leap year is calculated in 366 days, occurs in every 4 years. Dinner party 4 years of this thing divided by this birthday and the number of attending. One of the decides to estimate the survival group of the number in the Gomez law with respect to force of mortality. This is given. Comment on the choice of formula for the force of mortality. So, Gomez law is relatively simple expression for the force of mortality. So it has been found that the work of older ages, okay, so mortality. So 2020, the group was 64 to 72. Okay, so a Maycam form with a non-age related element might be slightly better. So the formula contains the exponential element to the majority and exponential element to mortality. So hence mortality increases relatively slowly with age. Okay. So next part is calculate the expected number of people that will be in the dinner, stating any assumptions you make. So assuming that the force of mortality is the constant for each year, so constant for each year. Okay. So the survival of the probability for another 4 years will be 3 into 4 72 8 and this thing is 64. So ABUX and PX calculation. So this PX is nothing but expectation of this table will be 0.04.99, 0.004 and 0.99 again. Next one is in that way we can calculate 67, 68 dot 70 till 5. So then put the values and calculate, and after that the expected number at the final will be 18 into 0.98 plus 8 into 0.98, 3 into 0.98. So 8, 26, 29, so 28.47. Now a new number is there, expected dinners of this in the 29th February 1960 joining the group, including this the dinners at 60 ignoring the interest and inflation. So the new number of 60 in the 1920. So the dinners are in 2024, 283, 23640. So therefore the expected cost is 60 into okay, so you can again calculate and do it just like the question before, and that's the end of the first question.